Good morning, everyone. My name is Sachin B, Assistant Professor in Department of Mechanical Engineering, MIT Mysore. Today, let us discuss about projection of solids. In the last classes, you people have come across projection of points, projection of lines, projection of solids. When it's come to the projection of points, point is a zero-dimensional object which doesn't have any thickness or any dimensions. When it's come to the line, a line is a one-dimensional object which have only one dimension, that is whether it may be length. And we have about the planes. When it's come to the planes, planes is a two-dimensional object which have length and breadth with negligible thickness. Now let us know about what is solid and what is the meaning of projection of solids. When it's come to the meaning of projection, projection is a Latin word which means throw forward. We will have come across a lot of things when it's come to the projection. When it's come to the example of the projector will go into project the light towards the screen. Means again there it is throwing the light to the forward movement of the light will be there. That is why the projector will go into work. Again here also the same thing. Projection means you people are projecting the object image, whether it may be front view or the top view or the side views. You people are projecting to the respective planes. When it's come to the projecting the respective planes, how the object appearance will be there. That appearance people are projecting towards the screen. Because of that, projection is called as the throw forward meaning by the Latin. Next, we have about the solids. When it's come to the solids, solid is a three-dimensional object which consists of length, breadth and thickness, which is and bounded by surfaces which may be either plane or curved or combination of both. Means solid may be any of the solids you people have come across, you people have seen, whether it is a tetrahedron, whether it is a cube, whether it is a hexahedron, cube, hexahedron, both will be same, or icosahedron, dodecahedron. A lot of things will come to the picture. Again there the prisms and also pyramids will be there. I will going to explain in detail regarding about the solids classification when it's come to the polyhedrons or the other type of polyhedrons. Means here I am saying that solid is a three-dimensional object which consists of length will be there, breadth will be there and the thickness will be there. And it is bounded by a plane surface, whether it may be a plane surface or the curved surface or the combination of both surfaces. Next is about the classification of solids. When it's come to the classification of solids, we have two types. One is polyhedrons, another one is solids of revolution. When it's come to the polyhedrons, polyhedron is a Greek word. The meaning of that poly means many, hedron means faces. Means polyhedron means many faces. That is about the polyhedron. Next, we have different types of polyhedrons. When it's come to the different types of polyhedrons, we have regular polyhedrons and other polyhedrons. Now I am going to discuss about the regular polyhedrons. When it's come to the regular polyhedrons, polyhedrons are nothing but the solids. We already know about it. It is one of the classification under the solids. Now we are talking about the regular polyhedrons. When it's come to the regular polyhedrons, solid bounded by only by plane surfaces, Its faces are formed by regular polygons of same size and all dihedral angles are equal to one another. Is nothing about regular polyhedrons have the same faces in all the sides. In all the sides, the same faces will be there, and it is bounded by all the regular polygons of same size. Means, for example, squares size will be there. The complete surface will be bounded by the square. That is called as the cube or the hexahedron. Next will be the tetrahedron. Similarly, we noted lot of examples over here. Just look at the example. This is called as a tetrahedron, which have the four equilateral triangular faces. You can just observe here one face behind that is the third face, and one is about the base face. The four equilateral triangular faces are present over here. When it's come to the cube or the hexahedron, you can just observe here 6 square equal faces are present here. Here one face is present over here, here another face opposite to this face, opposite to this face, again the top face and the bottom face. This is about the cube. Next we have the octahedron. When it's come to the octahedron, we have 8 equal equilateral triangular faces. Here 8 equal equilateral triangular faces are present when it's come to the octahedron. Next when we have about the dodecahedron, when it's come to the dodecahedron, we have 12 equal regular pentagonal faces. Here 12 equal regular pentagonal faces. Here there is no other shapes are present. Because of that we are calling it as a regular polyhedrons. Next we have the last one, that is about the icosahedron, which have 20 equal equilateral triangular faces. These are the 5 examples which are comes under the regular polyhedrons. Means here the regular faces will going to present, regular polygons of same size the faces will going to present, and all the angles are equal to each other and equal to one another. Because of that we are calling it as the regular polyhedrons. Next we have other polyhedrons. When it comes to other type of polyhedrons, other polyhedrons we are going to define as when faces of a polyhedron are not formed by equal identical faces. Means we know the difference between the regular polygon now and also other polyhedrons. In regular polygons all the faces are equal and the same size. When it's come to the other polyhedrons, here we don't have identical faces. When it's come to the classification of other polyhedrons, we have 2 types. That is, the first one is about the prisms and the second one is about the pyramids. When it's come to the prism, a prism is a polyhedron formed by 2 regular parallel polygonal faces. Means the opposite faces are parallel and the end faces are connected by the rectangular faces by the top face and the bottom face. Is nothing about here in the prism the bounded faces or the side faces are the rectangles or the parallelograms, which is get connected to the top face and to the base. That is why it is called as the prism. We have the different examples for the prism. The first one is about the square prism. You can just observe here. In this square prism, we have the base, we have the top face, which is bounded by the rectangular faces or the parallelograms. Again, when it's come to the pentagonal prism, we have the base as the pentagon and the top face as the pentagon, but it is bounded by the rectangular faces or the parallelograms. And here, this edge, in the square prism, also in the pentagonal prism or whichever the prism, the edges at the base is called as the base edge. And next we have the hexagonal prism. In the hexagonal prism, you just observe here, the base is the hexagon and the top face is also in a hexagon, which is bounded by the rectangular faces or the parallelograms. Here this face is called as the rectangular face. Again here these faces is called as the rectangular faces. You can just observe here in all the 3 objects, the faces is called as the rectangular faces. Next we have written here the rectangular prism. Here in the rectangular prism we have the same criteria we are going to apply here. The base will be the rectangle, the top face will be the rectangle, and it is bounded by the rectangular faces. And here I written the longer edge. In all the prisms, this edge from the base edge to the top edge, if the line will going to, if I draw in a vertical line, that is called as the longer edge. Here this is also longer edge, this is also a longer edge. Here all 5 different types of longer edges are present in the pentagonal prism. Again when it's come to the hexagonal prism, 6 different longer edges will go into present. And one more I have written about the triangular prism. Here everything is same, the base will be triangle and the top face will be the triangle, which is bounded by rectangular faces or the parallelograms. Here at the center of all the objects, the axis will going to lie in this manner. Means from the center of the base to the top face or the center, it is get connected with a chain line, that is called as the axis. Here the things are very much common, which we have the base as the square, means the top face also will be the square. Pentagon, in pentagonal prism also the same thing, base as the pentagon, top face as the pentagon. Hexagonal prism, base as the hexagon, top face as the hexagon. Again when it is come to the rectangular prism, base as the rectangle, top face as the rectangle, but the bounded surfaces are rectangles or the parallelogram. That is about the prisms. Okay, next in other polyhedron we have pyramids. When it's come to the pyramids, it's a type of a polyhedron formed by a plane surface as its base. Means plane surface of the base will be whether it is a triangle, square, pentagon, hexagon or whatever it may be, and the number of triangular faces which will get bounded from the base to the apex or the vertex. Means it have the apex, it have the base. From the base to the apex, it is bounded by the triangular faces. That is called as the pyramid. Next, with the some of the examples I have written when it's come to the pyramids. The first one is about the triangular pyramid. The second is square pyramid, rectangular pyramid, pentagonal pyramid, and hexagonal pyramid. When it's come to the triangular pyramid, you just observe here. This is what the base. That is nothing about the triangle. The base is triangle. This point is called as the apex. Here from the apex to the base edge we have the slant edge, and from the apex to the one of the sides, that is get bounded from the base to the apex, which is called as the slant triangular face. Means here one base is present, one apex is present, and three triangular faces will going to present with three slant edges. Next, when it's come to the square pyramid, again here also the same thing. The base will be the square, and it is get connected to the apex point as the vertex, and the slant edges are get connected to the base edges, and two slant edges will going to form the triangular faces in the square pyramid. Again here written the rectangular pyramid, the base will be the rectangle, and it is get connected to the apex with the slant edges and the slant triangular faces. And here from the apex or the vertex, an imaginary line that is drawn to the center of the base in all the pyramids, that is called as the axis. Again here also it is a pentagonal pyramid, this is an hexagonal pyramid. These are the some of the examples when it's come to the pyramids. Next type when it's come to the solids. First I have completed the polyhedrons. In that again regular polyhedrons, other polyhedrons has been completed. Next case is about the solids of revolution when it's come to the classification of solids. The solids of revolution is nothing about when some of the plane figures are revolved about one of their sides, that will going to generate the solids of revolution. For example, here I have written cylinder, cone and sphere. In cylinder, just observe here, the rectangle will going to be revolved. Rectangle will get revolved to get the cylinder. By the parallel surfaces of the rectangle, we will going to create the cylinder. Means if you rotate the rectangle about their axis in vertical direction, it will going to generate the cylinder. And again, when it's come to the cone, you just observe here, a cone is formed by the right angle triangle. Means we will going to rotate the right angle triangle. When you are rotating the or revolving the right angle triangle, the hypotenuse of the right angle triangle, will going to generate the cone. Next, when it's come to the sphere, when a semicircle will be revolved about one of its diameter, a sphere is generated. When a semicircle is rotated about its one of its diameter, it will going to generate the sphere. This is about the some of the examples of the solids of revolution. Till now I completed some of the basics which are related to the solids. In the classification we have the polyhedrons, and next we have the solids of revolution. Let's come to the polyhedrons. I completed the prisms, pyramids, and when it's come to the solids of revolution, these are the types. Okay, next the very much important topic when it's come to the projection of solids is about the methods of drawing the projection of solids. Means we need to know about the two important methods to project the solid. When it's come to that particular point, the first method is change of position method. When it's come to the change of position method, in change of position method, the solid will be placed in simple position. Then to get the final position, 2 successive or 3 successive stages of inclination should be done with respect to the planes. That is called as a change of position method. Now here I am considering the square pyramid. Just observe here, the base will be the square and it is get connected with the triangular faces, four triangle same shape of triangular faces from the base, and it is get connected to the apex or the vertex. Now, according to the change of position, in the first position, I am going to keep this solid. I am going to keep this solid in the first position as in the simplest position like this. Means here I am considering this floor as the horizontal plane and this board as the vertical plane. Now I am keeping this solid, that is nothing but the pyramid, in a simple position in the first position. Next, to get the final position, I will going to tilt this solid in the second position like this. Whether it is resting on edge condition or corner condition, it depends. Now, first position will be the simplest position. Second position will be, I am tilting this object with respect to the horizontal plane by giving some inclination. Next, I am going to tilt this object with respect to vertical plane with some inclination. Now, in all the three positions, we will going to write the front view and the top view, again the top view and the front view and the top view. In all the three positions, we are writing the front view and top view with respect to the planes. First position will be simplest position, second position will be the inclination with HP, and the last positions will be inclination with respect to VP. Then we are going to get the final position of this particular object. Similarly, we have the second method, that is nothing but axillary plane method. In axillary plane method, the solid will be placed in the simplest position at the first position. Next, we will not going to move this solid, we will not going to change its position of the solid with respect to the given statement. We are going to place the solid in the first simplest position. Next, to get the successive positions or the final position, we will going to bring the different axillary planes in different positions. That is very much essential to get the final position. But in the change of position, we are moving the object. When it's come to the axillary plane method, the object is fixed in first position, but we are rotating or we are bringing the axillary planes. That is called as the axillary plane method. Now, in our syllabus, we have only the change of position method in our syllabus. In our video syllabus, we have only the change of position method type of problems. We don't have axillary plane method type of problems. Next is about the very much important concept again, projection of solids placed in different positions. This is purely depends on if I consider the axis of the solid with respect to HP, VP or inclined to both the planes. The first one is about the axis perpendicular to HP or VP. If I consider this floor as the horizontal plane, if I keep the object like this, we know that from the apex to the base center, the axis will going to lie. Means axis is going to lie from this apex point to the base center. Now, this object or the axis is perpendicular to HP and the axis again parallel to VP. That is the condition. Again, if I keep the object like this, by considering this board as a vertical plane, now we know that from the apex to the center of the base, the axis will going to lie. Now here the axis is perpendicular to VP and parallel to HP. Next, again the second condition, parallel to either HP or VP and inclined to the other. When it's come to this particular point, here parallel to either HP or VP by keeping the object like this or object like this, or inclined to any one of the plane, that is also be considered. For example, I am going to keep the object like this by making axis perpendicular to HP and parallel to VP. When it's come to the second position, I am going to tilt the object. Now the object is get tilted, but the axis will going to be parallel to VP and inclined to HP. Again, I am going to tilt this object in the next position. Here the object, axis of the object will be inclined to both the planes. It will be get inclined to both the planes. Okay, here even if I keep the object in like this by keeping the object on the vertical plane by considering this board as a vertical plane, again here also the same thing. The axis will be parallel to HP and perpendicular to VP. Now I am going to tilt this object like this. Again it is the object, I am going to tilt the object like this. Again here the axis will be inclined to parallel to HP and inclined to VP. if I tilt the object like this. Okay, means in the second condition, parallel to any of the planes, inclined to any of the planes. And the last one condition is about inclined to both HP and VP. When it's come to the inclined to both HP and VP, the first condition will be like this, second condition will be like this, and the last condition will be like this. Means I am tilting the object with reference to the given inclination to both the planes. Means in second condition it is inclined to HP, and in the last condition it is inclined to VP. Then the axis of the object will be inclined to both the planes. Again, we can do this problem by keeping the object on the vertical plane, by resting the base of the object on the vertical plane. Again, inclination will be made to vertical plane, and last case the inclination will be made to the horizontal plane. Again, there the last condition is proves that is nothing but inclined to both HP and VP. Next is about 4 positions of a solid placed with its base on HP. Here I am considering the triangular prism. You just observe here, I am considering the triangular prism by keeping the triangular prism in the very simplest most conditions in all the 4 cases. Here you just observe here, the triangular prism will be resting on HP. Here the triangular prism is resting on HP. I am naming this triangular prism the edges as the A1, B, B1 and C, C1, and the axis will going to present here. If I project this, after writing the top view I am writing the front view. If I project this, the prism in the front view will going to look like this. When it's come to this particular case, here rectangular face will be parallel to VP. Means if I write the object like this, the rectangular face is parallel to HP. That is the condition. You just observe here, one of the face will be parallel to HP, because we already know that prism means it's one kind of polyhedron which have the identical faces at the parallel sides. Means the top and the base will be an identical face, and the bounded faces will be a rectangular face. Those are all identical faces. Here just observe here, the base will be the triangle and the top face will also be the triangle, and the base edges and the top face edges are bounded by the rectangular faces. You just, because of that, in this condition rectangular face will be parallel to VP. Okay, next condition will be most of the problems we are going to solve in our solids based on this second condition, because there the edge will be resting on HP, or the corner of the prism will be resting on HP. That is the condition. When it's come to this particular case, just observe here, the rectangular face will be perpendicular to VP. Rectangular face will be perpendicular to. If the condition that they will going to ask rectangular face will be perpendicular to VP, I can consider as the resting edge or the resting corner conditions. This is very much important to solve many of the problems. Again, the remaining part of the thing will be same. I have written the base on HP, I have written the front view of the prism on VP. Next, the third condition will be I am tilting the object. I am tilting the object by giving some angle to the rectangular face. Means here the rectangular face is inclined to VP. In this particular condition, the object is get tilted to some angle to the VP, but it is resting on HP. Again I am writing the top view, again I am writing the front view in this particular case. So development of lateral surfaces, most of the cases we are going to solve many of the problems by taking this particular condition. At the last, just observe here I have written the object by keeping the apex near to the axis. Apex near to the axis or apex away from the axis. Just observe here, in this particular condition, the triangular prism will be resting on HP, but the rectangular faces are equally inclined to VP. Means you just observe here, the rectangular faces are equally inclined to VP. That is the condition. Again I have written the top view, and again I have written the front view of the object. These are the 4 possible conditions to solve many of the solid problems. Next, again if I consider the same thing when it's come to the pyramids. If I consider this as the square pyramid, again I will going to solve the square pyramid in the same manner. I am going to keep the object like this, square pyramid object like this. Here 4 different triangular faces are present in the pyramid, because we know that pyramid means From the apex, it have apex and the base, which is bounded by the triangular faces. Okay, here I am going to keep the object like this by considering this as the vertical plane, the floor as the horizontal plane. If I keep the object like this, one of the triangular face will be, or the base edge will be perpendicular to VP. Is it clear? One of the base edges will be perpendicular to VP, not the triangular, because a triangular face is get inclined like this. The base edge will be perpendicular to VP. Next, again if I keep the object like this in the second position, here also the same criteria will going to apply. The base edge will be perpendicular to VP again. Here, sorry, in the first case it is parallel to VP, in the second case it is perpendicular to VP. Next, at the next condition, I am going to tilt this object. When I am tilting this object, again there, the object base edge will be inclined to some angle to the VP. Again here the base edge is getting inclined. And the last position will be like this. When it's come to this particular position, here the base edges are equally inclined to VP. That is the condition. When it's come to the first condition, by taking the square pyramid as the example, I am going to keep the object like this. Here the base edge will be parallel to VP and the base is resting on HP. Now I am going to write the top view and front view of the object. Top view on the horizontal plane, front view on the vertical plane. Again when it's come to the second condition, I am going to keep the object in the corner condition or in the edge condition. But if I keep the object like this, here I am going to consider this side of the base or this side of the base. Here the base edge will be perpendicular to VP, and in this condition also it is resting on HP, and the top view and front view will be written on the respective planes. And the last condition will be like this: I am inclining or tilting the object to some angle. When I am tilting this object to some angle, again here the base edge is inclined to VP to some angle. And the last condition I am keeping like this as the corner condition. In this condition, again the base edges are equally inclined to VP. These are some of the very much important key points to solve any of the solid problems. In the next session, I am going to solve pyramid problems. Thank you.